Hi, welcome back. It's time for more calculus. So in this one, it says use the three-part definition of continuity to determine if the given functions are continuous at the indicated values of left. So let's think about this. For a function to be continuous, the first thing that it needs to be is defined. The second thing is, the limit has to exist, or you can say the limit from the left equals the limit from the right. And the third thing is the function value must equal the limit. Okay, great. So let's do this. In this one, I want to see, is the function defined? So this is a piecewise function. That's okay. And I'm talking about at x equals -2. So I want to know, is the function defined at -2? So the way I'm going to do this is actually find the value, f of -2. And I can see this part of the piecewise function is when x is equal to -2. So I'm going to do 3 times -2 plus 2. I wrote plus 6. Shouldn't have done that. 3 times -2 is -6. Plus 2, I get -4. And then I see, sorry, I kind of moved some stuff around here. I got -4, so the function is defined. So, woo! First thing is true. And if you want to write the function is defined at -2, you can. This is good, though. The next thing is I want the limit to exist. So the limit as x approaches -2 from the left. I want it to equal the limit as x approaches -2 from the right. And so what I'm going to do is try this. And I'm going to say, okay, from the left, that would be when x was less than -2. Think about a number line. When is x to the left of -2? So I'm using this part of the function. So I'm going to say -2. And instead of x plus 6, I'm going to substitute that in -2. It's always the first thing we do when we're trying to find limits. And I'm substituting -2 plus 6. On the right-hand side, I'm using when x is greater than -2, because that would be like -1.9 or something, anything greater than 2. And I'm going to say e to the -2nd power plus cosine of pi times -2, or -2 pi. Now I'm going to just put this together. This would be -2 times the square root of 4 would be 2. -2 times 2 would be -4. And I want to know, is this equal to 1 over e to the second? It's not looking good. Cosine of -2 pi. Think about cosine looks like this. Cosine curve would just continue on the other side. So -2 pi would be over here, which would be plus 1. Those aren't the same. I can see that right now. So I can say, I could even do it there, or I can say this does not exist. So once I get to this point, I can say, therefore, f of x is not continuous. And you can't just say everywhere, because it might be continuous other places. And it is other places. But I'm going to say not continuous at x equals -2. And I'm going to say as limit as x approaches -2 of f of x does not exist. Boom, we did it. We just use the three-part definition of continuity. If you want to keep going and saying the function value doesn't equal the limit, you could do that too. Let's do another. So for a function to be continuous, 3 things have to be true. First, the function has to be defined. Okay, so let's do this. I'm going to say g of, we're talking about at pi, so g of pi. And what I need to look for right away is if there's a place where, oh, yep, right here, x is greater than or equal to pi. So I can substitute pi into this part of the function. If one of these was not, there wasn't a line under the less than or the greater than, meaning it wasn't equal to, we could stop right there and move on with our lives because the function wouldn't be defined. Okay, so I'm going to say e to the pi tangent of 3 pi over 4. Gross, but we're going to do this anyway. Okay, when I think about tangent to 3 pi over 4, I'm going to be thinking, okay, well, what is, you can do this lots of different ways. Like, what is sine of 3 pi over 4? What is cosine? Take the, and then you can take the ratio, because sine over cosine is tangent. So take a minute, think about this, do it any way that you possibly want to. I'm going to wait right here. Did you get -1? Great. Okay, so I have negative e to the pi power And I'm going to leave it like that. So the function is defined. The next thing I want to do is the limit from the left. So the limit as x approaches pi from the left of g of x equal to limit as x approaches pi from the right of g of x. And if I try this, I already did limit as x approaches pi from the right of g of x because it was this business up here. So I already know that's going to be negative e to the pi power. On the left, I'm going to do the same thing. I'm going to say this part of it, so e to the pi power, cosine of pi. Cosine, the way I do this one would be at pi negative 1. So I've got negative e to the pi equals negative e to the pi. Woo, I did it. So we have the function is defined. The limit exists. And then you need one more step. And you can label these 1, 2, and 3 like you did before. Or you can just write them like this and make me find all of them. That's fine. The limit as x approaches pi of g of x equals the function value g of pi, because both of those equal negative e to the pi power. And I'm running out of room down there, and I'm going to say, since I'm writing this beginning, I'm going to say g of x is continuous at x equals pi as, and now I have all that whole thing. Okay, so we did it. Let's do another one. So it says consider this function f of x to the right. Great. And I can see there's an m and a k and an x and some other stuff in here. So it looks a little bit different. It says what two limits must be equal in order for f of x to be continuous at x equals negative 1. So this looks like we are skipping some steps because we don't say the function is defined. But if you look at the places that this piecewise function is going to be connected, here, if this is f of x, what this would look like is I've got a function that is just 2. So y equals 2 anywhere where x is less than or equal to negative 1. So if x is less than or equal to negative 1, 1, 2. This is going to be a filled in dot because less than or equal to. Over here, negative 2 when x is greater than 3. So 1, 2, 3. 1, 2, 3. And it's a filled in dot down here, going this way. And what's going to happen, it's funny, that says 2, but it looks like it's a dot. It's not. What we need to know, this mx plus k, is there a line that connects these? And what would the slope and what would the y-intercept have to be? But I don't have to worry about is the function defined. If the limit from the left equals the limit from the right here and here, that's going to make my case. Like that's enough. So if I wanted it x is equal to negative 1, I would need this line, this 2, and I need to make sure that it's equal to this part, wherever this line is, the mx plus k. Okay, so instead of writing it like this, I'm going to write it as the limit as x approaches negative 1 from the left must equal the limit as x approaches negative 1 from the right of f of x. And what that would be 2 from the left, right here, and then whatever's connecting, so the mx plus k. But think about, remember what you have to do whenever you're solving for a limit, when you're trying to find a solution to a limit, when you're evaluating it, you substitute in your x value first. So x is negative 1, I'm going to put a negative 1 in here. What two limits must be equal in order for f of x to be continuous at x equals 3? It must be the limit from the left. Has to equal the limit from the right. Which in this case, left and right, which parts would you use? The 2, the mx plus k, the negative 2. Yeah, so you'd be using this part and this part now because this is where it's connecting between 3 and greater than 3. Okay, so I'm going to say mx plus k, but instead of x, I'm going to put in this 3. And then on the right, I get negative 2. So I have 3m. Oh, sorry, I can't resist. Just simplifying a little bit. Okay, determine the values of m and k so that the function is continuous everywhere. So that means the values that work for m and k down here must also work for m and k up here. So I'm going to write down 2 is equal to negative m plus k from that first problem. I'm going to write 3m plus k is equal to 2 from the second part. And now I've got to figure out what values would work for m and k. Well, we could just guess and check for a while, but that would be boring. And if you were hoping, can I use the systems of equations here? Yes. You can use substitution, elimination. You could graph this because your answer, this one's going to turn out nice, but lots of them do not. Like lots of them are really crazy answers. So don't expect just because you didn't get a nice answer that it's not the correct one. This one, we're going to have some whole numbers and stuff. So what I'm going to do is, I don't know, you could use elimination. I'm going to use substitution, but you can do whatever you want. I'm going to add m to both sides. So I'd have 2 plus m is equal to k. Now I'm going to go over here, 3m plus 2 plus m 2. There's nothing outside the parentheses, so I don't have to distribute anything, so I can just combine like terms. I would have 2 plus 4m is equal to 2. I am going to make sure I didn't miss anything. Oh, haha, I did. 3m plus k was equal to negative 2. There we go. Lucky me, I had old me to look back to, and I just looked to see if I was getting the right answer, and so I recognized it quickly. Here, I'd subtract 2 on both sides. I get 4m is equal to negative 4. Divide both sides by 4. I get m is equal to negative 1. But I can't stop there because I need a k. But I know k is just equal to 2 plus m, which I know is negative 1. K is equal to 1. So the way that you're going to check to make sure this is actually the case is if I set up f of x, I've got this function, I've got 2, and instead of mx plus k, if I put in negative x plus 1 and negative 2, if I still did the same function, piecewise function, if I substitute in negative 1 here and here, would I get the same answer? Okay, so 2 equal to negative 1 would be positive 1 plus 1, 2. 2 is equal to 2. On the right hand side, negative 3 plus 1 would be negative 2 is equal to negative 2. Oh, we did it. So we know we're good. Huzzah. Did you want to do one more? Is that what I heard? It's funny because you would think I couldn't hear because you're on that side of the computer and it's actually July when I'm doing this, but let's do it. I can almost hear the eye rolls from your home, so it's okay. You can do it. That's the beauty of this. You can eye roll and I can't see it unless you're watching this in front of me because I have no idea what the plan for the school year is yet. So if you're watching this in front of me, just be careful of the eye rolls so I don't see all of them and get hurt, you know. Okay, g of x is to the right. What two limits must be equal in order for f of x to be continuous at x equals negative 2? Well, same deal as before. First I want to check, is the function defined at x equals negative 2? It is because of this line, the less than or equal to, and also at 3. It is because the less than or equal to by 3. So I don't have to worry about that part of the function when I'm trying to find these m and k. Like I'm not worried about, or three-part definition of continuity. I'm not worried about is the function defined because I can already see that it is. And the function value is going to equal the right-hand limit for negative 2 and the left-hand limit for 3. So what limits must be equal for this function to be continuous? Well, really plainly, from the left, limit as x approaches negative 2 from the left has to be equal to limit as x approaches negative 2 from the right. And that's all I'm going to put for right now. I'm going to worry about the rest in a little bit. So actually I'm going to write this down there. Limit as x approaches negative 2 from the left of f of x has to equal the limit as x approaches negative 2 from the right of f of x. This is a piecewise function at negative 2. That's like one of the first joints. We're trying to make it all fit together. Okay, to be continuous at x equals 3, limit as x approaches 3 from the right, or I'm sorry, 3 from the left. It really wouldn't matter of f of x. Oh no, I made a mistake. I said f of x and all of this was g of x. So hold on, I can fix it. Whew, I fixed it. Okay, so it doesn't look nice, but that's okay. Limit as x approaches 3 from the right of g of x. And so I'm going to do that down here too. If you have an assessment with something like this on it, and it says justify your answer using limits or show your work using limits, that's what it's talking about. Anytime you use limits as a setup in a piecewise function like this to prove continuity, you have to show this part, like this setup of the limits. Don't just start writing, well, I know what they're going to be equal to. Me too, but we show it anyway. You always want to be really just clear in what you're saying, that you understand all of this, because really it's not so much that you can do every step, it's more that you can communicate effectively using math. Okay, limit as x approaches -2 from the left. I'm going to use this part, which is k x squared plus m, and instead of x, I'm going to put in -2. On the right, it's connected to this part. I can see the 4x plus 1, but instead of x, I'm going to substitute in -2. If I do the other one for 3, limit as x approaches 3 from the left, that would be this part, the 4x plus 1. 4 times 3 plus 1. And then for the right, I've got kx minus m, but instead of x, I'm going to write 3. Now I've got these messy things, but I've got some k's and m's over here, k's and m's over here, and now I can use a system of equations to put these together. So stop this video, or I'll stop it for you if I use this on Edpuzzle, and try this. So -2 squared is 4. K plus m is equal to -8 plus 1. 4k plus m is equal to -7. Over here, 12 plus 1 would be 13. 3k minus m. Okay, and then I'm going to solve this one for m. So subtract 4k on both sides. I've got -7 minus 4k. 3k minus, don't forget parentheses. If you did, that could be an error. -7 minus 4k. Because you need to distribute the negative sign. So you'd have plus 7 plus 4k. Combine like terms. 7k plus 7. Subtract 7 on both sides. Oh man, that was behind my head for a little bit. So subtract 7 on both sides to get 6. Gross, but that's okay. K is equal to 6/7. If k is 6/7, m is -7 minus 4 times 6/7. 24/7. Oh, if I can leave my answer like this for m, or I can keep going and I can say, well, this would be 7 times 7 is 49. -49/7 minus 24/7. -49 minus 24 would be 59, 69, 73. It'd be amazing if I didn't mess any of this up. But hey, I can see what I did before. I know that this is right. But if you got an answer like this on a test or quiz, I'm guessing you would be freaking out. This is still the appropriate answer. But what you need to do is go back up here and substitute in k and m, and then just substitute in for -2, substitute in for 3, and see, does this actually work? Is my left-hand limit equal to my right-hand limit? You did it. You did it. My chair squeaked. My chair squeaked. But you did it. I think you're great. Keep on keeping on. You got this. We got it together. Let me know what questions you have. Bye.